Welcome, everybody. Thank you so much for joining us this evening. My name is Rebecca Poole, and I'm the Director of Membership and Communication for the Council of New York Cooperatives and Condominiums, or CNYC. The Council of New York Cooperatives and Condominiums is a membership organization for co-ops and condos, and as such, we're funded primarily by membership dues. We provide education, like this webinar tonight, information, and advocacy for New York City's co-ops and condos, and we've been doing so for over 40 years. On behalf of CNYC, our speakers, Darren Johnson, Lee Hoffman, and Garrett Modeste, and our Executive Director, Marianne Rothman, I would like to thank you for spending your evening with us and welcome you to this, the 10th class in our Sustainability with Affordability series for Local Law 97. CNYC has long supported the climate goals of Local Law 97 and has worked both internally and externally for years to champion its implementation through incentives, abatements, rebates, and subsidies in place of penalties and fines in order to enable our member buildings to meet the city's necessary but ambitious carbon reduction goals. Everyone on CNYC's board, as well as CNYC's staff, is a homeowner in a cooperative or condominium. Like you, our buildings face many widespread financial and regulatory issues, of which Local Law 97 is just one component. CNYC continues to stress the cost of city rules and regulations at every opportunity and the fact that it doesn't work to enforce rules that people cannot afford to follow. We hope that you will subscribe to our e-blasts and join our advocacy efforts to maintain the affordability needed for all shareholders and unit owners to remain in their homes while complying with city rules, regulations, laws, and codes. Please feel free to email me for more information. We hope that in this evening's class, you will find cost-effective measures to help you get through at least several initial compliance periods. And just a brief reminder before we get going that CNYC will be hosting its all-day annual housing conference on Zoom on November 17th. It's a Sunday. There will be 42 classes to choose from in three different periods. There are 3 classes on Local Law 97, 1 class on solar, but so much more. Regardless of what you're looking for, we have a class on it. We encourage you to visit our website, cnyc.coop, and review the brochure. And now for tonight's class, it is my pleasure to introduce your speakers for this evening. Darren Johnson is a Senior Account Manager for Bright Power, a provider of energy and water management services for real estate owners, investors, and operators. Darren is an expert in assisting multifamily and commercial properties in the greater New York City area identify how to improve energy performance by reducing their energy consumption and costs through better energy management. Darren and Bright Power have also provided CNYC with assistance in understanding some specific regulations and ideas for how the rules can be implemented and have done several classes for us, so thank you. Lee Hoffman is the co-founder and president of Runwise, the leading smart controls platform that operates the key heating and water systems more efficiently in 7,500 buildings throughout the country. He's a multi-time entrepreneur that has been building technology companies since 2004. Garrett Modeste from Kelvin Systems is a sustainability consultant with a background in social impact and 8 years of experience aligning public and private interests. Passionate about implementing resource-efficient retrofits, he leverages rebates from utility companies and government incentives to remove financial barriers to lowering emissions while improving comfort. And now onto our program. Please enter any questions you might have into the chat, and we will pause during the presentations. We'll read them in. We'll get you answers. And then at the end of the presentation, there'll be a larger Q&A. Thank you. Darren, over to you.
Thank you, Rebecca. Thanks for everybody for joining us tonight. Let's see. Just a little bit to add about Bright Power for those who may not be familiar with us. We are a registered Energy Star service and provider partner. We have a proprietary database that includes over 100,000 buildings and 15,000 properties, not only in the New York City area, but across the United States. We have performed close to 3,000 energy audits and have helped buildings successfully complete retrofit upgrades in over 600 buildings. So in prior webinars, we have discussed the importance of developing an energy plan. What we want to be able to focus on tonight, and what Lee and Garrett are going to be talking about, is some of the short and medium-term goals. So when you're thinking about your energy plan and thinking about the things that you can do now to be able to drive down your energy consumption and carbon emissions, while you're thinking about long-term positioning, what we're going to be talking about is that those that have shorter paybacks that can reduce their energy consumption and your carbon emissions, they're going to be financially achievable, hopefully within the next year or two, but within a 3-year period of time for you to be able to implement. One of the things that I just want to review with everyone are the building systems that impact energy consumption. So that you can see here, there are many different aspects of a building and the mechanical systems that impact the energy consumption. You have the building envelope for those who may have mechanical ventilation, heating, which we're going to be focusing on tonight, domestic hot water, cooling, in-unit energy consumption, thinking about appliances, thinking about lighting and other things that are going to be plugged into the apartment outlets, pumps and motors around the building, and then just overall lighting in the building. Our focus tonight, though, is going to be on heating. So to be able to kind of lay the groundwork of why we're going to be focusing on heating, this is what I find to be a fairly typical building in New York City that has a central boiler system, primarily going to be steam heated. So for those that may not be familiar with the building energy exchange calculator, it's a publicly available calculator that you can pull up any building that is submitting for annual local law 84 benchmarking, and you can see how your building is performing. So for this one, just so everybody understands what you're looking at, the blue represents the electricity carbon emission for the building. The green represents the gas. So it is fairly obvious that most of the carbon emissions, and this is fairly typical, come from the gas, which is the reason why we're going to be focusing on the heating system tonight. Because in this graph, as you see in figure 5, what we have is that this is when you break down the energy for the building. You can see that about 83% of the energy in a building is between space heating and domestic hot water. Those are the systems that are using fossil fuels. Those are the systems that are using gas. And then when we take a look greater into detail into the gas consumption, and this is for the example building, it's about 3/4 of the gas consumption goes to heating. So that is the reason why when we talk about the potential solutions for buildings tonight, it's really focused on this heating system because it is the predominant contributor of carbon emissions for most multifamily buildings, especially those with a central boiler system that have radiators, convectors, and steam heating. So just to kind of talk about a basic steam boiler system, just for anybody who may not necessarily be familiar, just to kind of get this in familiarity with everyone for our discussion tonight. Think about it in 3 different kind of components. There's the generation component, which really is your steam boiler that's in the basement. There's the distribution, which is where the steam, as that water is heating up and that steam is produced and it's coming out of the top of the boiler and it's going through the steam piping. And thinking about the risers as they move through the building and then as it distributes across the apartments on each floor. And then that leads to the radiators. So we have the generation, the distribution, and the terminal units. One of the things that I would just like to say about these 3, and the reason why we're going to be focusing on tonight on distribution and we're going to be focusing on the terminal units, is that on the generation side, that when you think about a boiler, basically just heating up water and just creating steam, the replacement of that equipment is predominantly when your efficiency gain just by putting in a new boiler, probably somewhere between 1% to 5%. There's a little bit there, but it's not the lion's share of the efficiency gain that you can get in one of these types of systems. It's really focusing on the distribution and the terminal units. And that's what Lee and Garrett are going to be speaking about tonight, are their solutions to be able to help improve this distribution and with the terminal units as well. So with that, I'm going to turn it over to Lee, and he's going to be able to talk about their service and their products.
Awesome. Thank you so much, Darren. I think that was an awesome explanation. It's so funny because when most people think about carbon emissions, they think of cars, right? You think of the Tesla, and when you think of even buildings, you think of like fancy solar and electric. And I think what Darren pointed out that's so interesting is that most carbon emissions in cities are coming from buildings, and it's really coming from that big heating system. So I'm going to walk everybody through, I'm going to load this presentation. And what I'm going to start with is kind of a controversial idea, and I'm going to give some backplot to this, which is I have actually been on co-op boards for the last 17 years. I'm currently the treasurer of a 500-unit Upper West Side co-op. So I know what it feels like to be on a board, and especially when you get new legislation like Local Law 97, there are literally a billion possible ways to address your carbon emissions, and it's incredibly overwhelming. And the first thought I think I had, and I think most people I talk to that are on boards have, is, oh my God, this is going to like bankrupt my building. How am I ever going to get my building to be compliant? And what I'd like to leave everybody with is kind of a different take on Local Law 97, which is, at least for the next 10 years, if you implement Local Law 97 the right way, it actually will be one of the best things you've ever done to your budget from a financial and operating perspective, in addition to a climate and carbon perspective. And the reason is that there are very specific measures that are out there today that have remarkable ROIs, meaning return on investments, where whatever you put in, you're getting the money out very quickly, and then you're adding a ton of money to your budget, such that regardless of the climate impact, you should be making them in your building anyway. And so I'm going to talk about one of them, and this is where my company focuses. They're called smart controls. But there are a number of these measures, and I highly encourage everybody, when you're thinking about Local Law 97, to really look at which measures can deliver money back to the budget in a fast, timely way. Because if you do that, not only are you making good financial investment in your building first, but then you know really how far you have to go to make the larger, more costly, less ROI-focused investments later, and you'll have more money in the budget to do it. So I'm going to take you back to the beginning to tell you how we discovered the problem and why smart controls fit in. And then I'm going to kind of take you to how it fits into Local Law 97 compliance. So this is a gorgeous photo of me and my co-founders. The company started really because my co-founder, Jeff, in the middle there, was managing 150 multifamily buildings for a single owner for about a decade. And Jeff was paying the oil and gas heating bills on these buildings and would notice gigantic discrepancies between one building and another, like 80, 70, 80, 90% differences in oil or gas usage per square foot. And this just didn't make sense to him, how a similar set of buildings in similar neighborhoods, similar vintages, could be using wildly different amounts of energy. And so Jeff came to me and my co-founder, Mike, and we started looking at this, trying to figure out why this was happening. And what we figured out very quickly, and I will bet, basically, I would make a bet with everybody on this call, $1,000, that if we were to look in each of your buildings, over 80 to 85% of your buildings would be running on your heating system is running on incredibly antiquated technology from the 1960s and 70s. Even if you just bought a new control, there's a overwhelming odds that it is literally the same technology that was being used in buildings in the 1970s. And the result of this is just a tremendous amount of waste financially and a ton of carbon waste. And to show this more visually, if you go down to your basement to know if you have one of these old controls, it probably looks like this one on the left. And this is what we replace it with on the right. And I'm going to walk you through why this control is so antiquated. This is the standard control. I'm not going to name the brand, but it's in basically 95% of buildings in New York that are steam or hydronic heated. This control, number one, the software that runs it, the code, the logic, is literally printed on the board. So your iPhone gets smarter every other night with a software update. Your controlling potentially hundreds of thousands of dollars of heating never gets smarter. It's running what's known as an outdoor reset algorithm, which is effectively just a timer. It is literally a glorified timer, and all it knows is the temperature outdoors. It has no idea what the temperature is indoors. So what ends up happening is somebody complains, maybe even 10 or 15 years ago, the property manager or super gets the complaint at 10 p.m. and they have no idea what the temperatures are inside. So they hear the complaint, must be cold. They go down to the basement and they turn one of these knobs that you see, and now the building gets hotter. And this is literally how almost every building in the city works. These things are also not connected to the internet, so you have no visibility on what's happening unless you go to the basement. The reason this is so ineffective is that you end up vastly overheating the building. If you don't know what the temperatures are inside, you always overshoot. And the way to see this in a non-empirical way is drive down any street or avenue in New York City or Chicago or Boston or anywhere that gets cold in the middle of February and count the number of windows that are open in those buildings. That is literally just money and carbon emissions going out the window. So how do you solve this problem, right? You have this antiquated infrastructure, legacy technology from the 70s. It's still being sold in most cases today. Jeff, his initial view on the market coming from being an owner of buildings was, if we want to replace this infrastructure in the 12 million buildings that exist in the United States, we need to be able to deliver something that doesn't take 5 years to get paid back once you install it, but closer to 5 months. And so we took a very first principles approach to how you would actually do that. And what we ended up building is what you see on the right here, a computer and wireless sensor network that can be installed anywhere from 3 to 20 times faster and cheaper than the historical controls, because it's done completely in wirelessly. In fact, we actually invented a wireless chip and protocol, literally the microprocessor, that allows us to put an entire wireless sensor network in a building in a few hours with no hard wiring, and every single device and every single battery lasts 10 years without having to be changed. Combine this together with really smart software, you can start running the building in a much more efficient and effective way. The net result is an incredible financial payback. The average building that we have cuts their fossil fuel and heating usage by over 21%. The 75th distribution, meaning not even the average building pays for itself in 9 months. The average is about 5 months. So meaning you put $1 into installing smart controls like Runwise in your building, and you make your entire investment back in 5 months, and then you're making on average 4 times your investment every year going forward. What this means is that if I offered you an investment where you give me $100 outside of your building and you get the $100 back in 5 months, and every year afterwards you get $400, you would immediately say, how much money can I give you? And that is the reality with smart controls if they're implemented correctly. This is also why so many buildings have adopted this technology. Literally every single block in New York City, Boston, Chicago, everywhere else, we probably have 5 buildings with Runwise installed. This is an actual map of New York City. You can see the pins are literally overflowing. Any one of your building, I would personally guarantee there are probably a handful of other Runwise buildings literally right next to yours if we're not already in your building. And we have a ton of customers like this. The way we do this is we install wireless temperature sensors in about 15 to 25% of the spaces. And then we use those sensors to dynamically predict what the temperature should be in the building. So instead of somebody complaining and the super running downstairs and turning a knob all the way up, and now the average building in New York City runs at 78 degrees, we have temperature sensors in there that actually can run the heating to a specific temperature. And the reason this is really important is that a wild fact we figured out a couple of years ago is that the difference, 1 degree of temperature in your building, the difference between 73.2 and 74.2 can be up to 10% of your energy budget. So if you don't have sensors in your building in a large number of spaces, there is no way you're going to come anywhere close. On top of that, what we also found over the years is that a single temperature inside is actually not what keeps people comfortable. So I don't know if anybody else has had this experience. It's like November 1st, it's the first cold day, it's 55 degrees out, and you're like, oh my God, I need to put on a fur coat, right? Whereas in March, it becomes 55 degrees and it's like, I could go out and wear a bathing suit, right? People's perception of the same temperature changes not only throughout the year, but throughout the day. At nighttime, people need the temperature different than they do during the daytime. When the weather changes outside, when it drops precipitously, people need a higher temperature indoors. When it's rising outside, they need a lower temperature. So by dynamically adjusting what the temperature set point should be, you can eke out an extra 1 to 2 degrees of saving while making tenants, more people in the building, more comfortable. And this is really the heart of how you can cut the energy or heating bill by 20 to 30%. In addition, for free out of the savings, you get things like everybody in your building gets remote access to the heating system on their iPhone and on the web or their Android, meaning that not only can you see what's happening and make changes if somebody complains from 100 miles away, but you can detect critical issues like scalding hot water. Roughly 30% of buildings right now are making hot water that's above 130 degrees, sometimes up to 170 or 180. That's literally coming out of the shower. And it goes on for a decade or more without anybody knowing until somebody, usually a child, gets burned. Or your heating system goes down. Most buildings right now, in your buildings, when your heating system goes down, it's because 8 hours later, somebody notices it's cold. Instead, real-time sensors can tell you in seconds when your heating system goes down, and somebody can be dispatched to fix it before anybody even notices. These are things that get detected and make the building and the tenants safer with that, and they're completely free out of the economic savings. The reason I'm going through this is that the byproduct of saving money and making your building run better is also a tremendous amount of carbon emission reduction. And this is where Local Law 97 comes in. If you were to rank every measure possible to reduce Local Law 97 fines on a per dollar investment basis, smart controls is definitely one of the top ones for in most buildings. In fact, in the vast majority of buildings, you can get to 2030 or even 2035 simply by installing smart controls and doing a handful of other measures like insulation, venting, potentially one other measure. And you're going to end up adding a ton of money back to your budget while getting in compliance with Local Law 97. This is why Local Law 97 for rent-controlled and rent-stabilized buildings actually mandates that you put this technology in. For non-rent-controlled buildings like most of you folks, it just happens to be the most cost-effective way to get Local Law 97 compliant. In fact, the average building in our system, 7,500 buildings, about 4,000 probably are above the 25,000 limit. The average building will see a $20,000 to $25,000 per year reduction in fines, again, while adding a ton of savings from their energy bills back to the budget. So this is why I think it's so critical to really look at Local Law 97 differently. And the way that I recommend looking at it is, how do we make investments in our building that are good financial investments that also make us Local Law 97 compliant? And that is really what I encourage most boards to do. Smart controls are obviously one of those measures. I'm going to take you through some example buildings because these are useful. This is 1 West 67th Street, super famous building, Hotel des Artistes. If you've ever been in this building, it is absolutely gorgeous. It's a landmark building. It also happens to have literally 2-story, 20-foot windows in every building that are single pane. So if you want to talk about a building that is literally, the shell is about as energy inefficient as humanly possible as this building. And simply by replacing the controls without changing anything else, we were able to reduce the energy consumption, the heating bills by 34.2%, which had a tremendous amount of LL97 fine reduction. You can see about $82,000 a year in LL97 fine reduction. And as an example, in this building, this building was actually on gas, and Con Ed actually paid for 85% of this installation because it was eligible for a rebate. So this was like a home run, no-brainer. And then we have a ton of other buildings that are, less glamorous, but are just your standard co-op and condos. This is an ACAM building. at Francis Lewis Boulevard, 26% reduction. Another ACAM building, 9 Terrace Circle. This is an Orchid building, 240 East 55th. I actually used to live and was on the co-op board of the building that was attached to this building, 18% reduction. These are very typical, prototypical results. We are on a large number of these types of buildings, Orchid, Element, First Service, ACAM, et cetera. So we have a lot of experience with these types of buildings, and they're really no-brainers. And it's really comes down to, as Darren was talking about, simply running the heating system less to make people comfortable instead of overheating and roasting them. And if you can use technology to do that, it's a triple win, because not only do you add a lot of money back to your budget, you get shareholders that are a lot more comfortable and happier, you make them safer, and you get in compliance with local law 97. So I'm going to take a break there. I see we're getting some questions. Rebecca, do you want to do the questions at the end, or do you want to take questions now? Oh, wait, maybe I'm
muted. I'm sorry. No, I was muted.
Yeah.
Sure, we can do some questions now. I'm going to actually just ask one myself that I have before I read the ones in the chat.
Go for it.
So in terms of the savings and the fine reduction, do you find that there's any difference based on the fuel source, like if it's number 2 oil versus gas, or is it sort of just the same?
Not on a percentage basis, but obviously oil is much more expensive on a BTU basis than gas is. So you tend to have a larger magnitude of savings on oil buildings. However, the advantage of gas buildings is if you're on Con Edison or National Grid, they will actually pay to install Runwise via rebates. So you have an incentive, you have a benefit there. So you sort of have costs and benefits on both sides.
Okay, here's the questions. First one, we have a heat timer controls and sensors in 14 representative apartments. Installing the apartment temperature sensors reduced our consumption by about 20%. Would installing Runwise offer an additional improvement? And why? How would that work?
Yeah, so heat timer is kind of the old school, and their newer version with the indoor temperature sensors is definitely a huge improvement. That's why you're seeing this. Whether you use a heat timer or us or anything, you definitely should have like a apartment temperature sensors in a percentage of the building. Our average, so we've taken out about 780 buildings worth of heat timer platinums with indoors. In fact, Lefrak replaced every one of their heat timer platinums with indoor sensors with Runwise. The average savings from a transition from heat timer to Runwise is about 12.5%. So it's not nearly as good as just doing Runwise itself, but there is some savings. It really depends on what your fuel budget is and how the building is operating to know if it's a good ROI. And if you want, Andy, I'm Lee at runwise.com. If you want to email me, we're happy to do an analysis on it. If the ROI doesn't look good, I would probably tell you don't make a change. If the ROI is really good, then, maybe it's something you consider.
Is there a percentage of apartments that you tend to put the sensors in, or do you just look at the buildings, and see like, oh, this has many different elevations? Like, how do you determine how many apartments should get sensors?
15 to 25% of the spaces. If it's a rebate, so if Con Ed or National Grid is paying, we have to do 25%. Some buildings do 100% because they want, when somebody complains, to be able to say, no, it's 76 degrees in your apartment, we're not raising the heat anymore, or something like that. But that's generally our target and where we aim, where we think anybody should be at least 15%. And we like to have coverage on every single riser on at least 1, if not 2 floors, and then extra sensors for apartments that are typical, either problem apartments or historical complainers.
How does the Runwise system coordinate with thermostatic radiator valves, or does it?
So they don't talk to each other. They're totally separate technologies, but they work together. So all a thermostatic radiator valve is going to do is it's going to essentially balance the heat. So, and Kelvin's like a super hyper version of this, right? Like way better. In a typical building, the steam goes on, gets hot, and then it goes off for a period and it gets cooler. And a thermostatic radiator valve is just going to like compress that up and down a little bit. It doesn't change how much energy is actually being used at the central plant. And that is really where we focus. And Kelvin obviously is much more sophisticated and can both lead to reduction and make you almost like a perfect straight line, which a thermostatic radiator valve isn't going to do.
Right.
Sorry if I'm going to your pitch, Garrett.
I was going to say the next question is actually about how Runwise and Kelvin, a smart radiator module like Kelvin would work together, but we'll leave that I think later for Garrett to get to.
The very short answer is we have an API integration. We connect and we talk together. We've done dozens and potentially hundreds of buildings for Lafrac, Fairstead, et cetera, where the two play nicely together and you just get the benefit of both.
How would you deal with a building where the super is not comfortable with the technology? Are there classes? How do you deal with something like that?
It's a fantastic question. When we originally built the technology, we were wide-eyed optimists that we just built technology and everything else would solve itself. And we quickly learned that was not the case. So part of our service is a very low cost install, and then we have a yearly fee, which is usually a very small percentage of the savings. So usually making 4 to 6 times that fee in savings each year. The reason we have that fee is we have a dedicated human who is a boiler and heating expert who does 2 things. One, they're there when your super has a question. We have a 24/7 support line with trained experts so that when the super has a question at 4 a.m., they can call and somebody will pick up and know what they're talking about. The second is they will do trainings with every single person that works in your building to educate them on the system. If they don't see them using it properly, they will call them and be like, hey, can we come out and talk to you and show you how to use the system again? Because the best technology is only as good as the people who use it. And if you don't have your team engaged and knowledgeable on how to use something, it's never going to be effective.
Are there any other big variables with energy savings within the system to be aware of? So I mean, there wasn't really, I guess, between oil and gas, but are there items where you find, oh, this building, is saving so much more money because they, have windows like the artiste, I guess, or
Yeah.
I don't know.
Steam systems, particularly 1 and 2 pipe steam systems, are by far the worst abusers of heating. Hydronic is more efficient just naturally, but so you might see 25 to 30% on a steam. Hydronic, you might see 15 to 20 on average. And then heat pumps, you might see 8 to 12%, something like that. So the central system is the biggest determinant. And then there are other issues that can be problems, like if you have distribution issues in the building or severe boiler issues, like those are things we'll tell you about, but if you choose not to address them, we'll save you money. We'll save you 10, 15, 20%, but like there's probably another 30% that you could save by fixing the core issue in the building.
Yeah, no, and I'd like to add to what Lee was saying, because that's really important, that indoor temperature sensors are not going to balance your steam distribution. They're going to identify those problems. They're going to tell you where the problem areas are. But for like a 1 pipe system, you need to go through steam balancing so that you can get the most benefit out of indoor temperature sensors. You need to make sure that you have proper venting to be able to get the air out of the system so it is equally distributed across the building to the furthest point, because then you're going to maximize your savings with the uses, the use of an indoor temperature sensor system back to the controller. And in a 2 pipe system, if you're not changing steam traps, or you haven't, depending on what you're doing, whether it's orifice plates, if you installed them, great. If you have steam traps and you're not replacing them on a regular basis, then that is additionally inefficiency in the system that cannot be solved by indoor temperature sensors. So part of that is to reiterate what Lee was talking about. That distribution system has to be functional, and it has to be maintained, especially if you're going to just keep with steam traps. Those things are going to fail on average every 5 years. You need to have a protocol for doing that, because then you're going to maximize your savings using a system like this, like what Garrett's going to talk about, because otherwise then you have inefficiencies that aren't being addressed and you're not maximizing your savings from these types of solutions.
It is the best point made tonight, what Darren just said. There are like a handful of things that are such incredible ROI financial no-brainers for a building. And some of them look sexier like Runwise, but the unsexy ones are just as important. Installation, venting, steam trap maintenance. These are literal no-brainers. And if you have a steam or hydronic system, you absolutely should be looking at these things and making sure you're doing them Obviously, smart controls are incredibly effective as well, but these are no-brainers where like literally they pay for themselves in like a month or two if you do them properly.
So the next question sort of, I think, goes into where it was done improperly, perhaps. So it says, our building tried a system like this without success. Our system is a single pipe system with uneven distribution. Why should we retry? And I would say, what things should they look at in terms of like why maybe the former one wasn't was unsuccessful and how it could be improved upon?
There are variety. So there have been literally a minefield of companies that have tried to do this and been super unsuccessful. And there are a variety of reasons. One is their technology wasn't right or very good. Two is they had no human backing it to make sure people were actually trained and problems were addressed. So there are a whole cascade of things. What I would look at is twofold. One, has the provider actually gotten to scale? Are they in thousands of buildings? Because if they're not, there's a reason why, right? And the second is, can they show you published data on thousands of buildings to prove their results? We publish all of the data from all of our buildings anonymized. So you can literally take the fuel bills and recreate the savings that we're showing on 7,500 buildings. If a vendor can't do that or won't do that, it's because they're not actually delivering savings. And so that the transparency of asking for that is the way that you suss out whether or not you're going to end up with a bad experience or a good one. We have done thousands of buildings where literally they had tried something with indoor sensors and it was a disaster. I mean, there were controls that used to run the heating, the boiler, like literally only off indoor temperature, meaning like one sensor would be out or off because it was near the kitchen and you'd have the boiler off for like 17 hours. I mean, crazy things like this. I've seen insane stories. And just ask for the data and the results to prove it. Or ask for customer references, right? If they can't give you customer references and numerous of them, there's something wrong.
We have plaster walls. We have problems with our internet Wi-Fi on the far end of our apartment in our suite. How would the wireless sensors work in our building?
So we do not use Wi-Fi. We do not use any type of cell service like in the main units. We developed a wireless protocol. You can think of it as like a super Wi-Fi that we install and is dedicated purely to this. We do this both for cost reasons because you can't really depend on Wi-Fi, and Wi-Fi is extremely expensive to run into a building, and for reliability and security reasons. So what we do is we install a device, again, all battery powered, that requires 4 screws every between 4 and 10 floors, usually in a stairwell. It's all battery powered, takes literally about a minute per repeater, and those repeaters broadcast signal to the entire building. Each sensor is also battery powered. So again, 30 seconds in an apartment, you can use double-sided tape or 2 screws, and we're in and out of the apartment. And all of those devices last 10 years on a battery. So we have designed the protocol to have way extra power so that it makes sure it gets reliable signal in every nook and cranny of every apartment in the building. And we've designed that protocol to be very battery efficient as well, so you don't have to go back into those apartments for a decade to change anything.
So there's another question that's sort of connected to this. What communications infrastructure is required to operate Runwise, for example, static IP? So do you need anything from the building?
Nope. We bring in a dedicated. So this is another thing that I think several control companies have done wrong, which is they're like, oh, well, you have an internet connection in the building. Let's use that. We're in so many buildings, including we do all the MTA, LIRR, and JT buildings. This is critical, not only private infrastructure, it's critical government infrastructure. So we take security incredibly seriously. We do not use or share internet. We bring a dedicated wireless modem into the building that runs over an encrypted tunnel. It never touches the internet. This is purposely to make sure that all of this infrastructure in tens of thousands of buildings is secure and safe, and we do not need any lines or internet already in the building to do it.
Once sensors are installed, how much work is involved with rebalancing?
So that is depending on how badly your building is balanced already. So some buildings we go into, and there's a couple degrees of 2, 3, 4 degrees of variance, which in an older building is incredible and the best you'll ever do. Some you go into and there's 17 or 18 degrees, right? And like what having the temperature sensors does is it shows you where the the balance issues are, and helps you diagnose it, and then helps you measure whether or not venting, like balancing, master venting and balancing, actually corrected it effectively. And that's really where data is power in fixing those types of issues.
Are there ever any cases where that couldn't be done? I mean, I'm just thinking like in my apartment, we have we're one of the exterior apartments, so we have like 3 different elevations. We have a balcony, we have bad windows, so we're like just but then there are internal apartments, right, that don't really have that. They just have the one elevation. So obviously our heating is usually out of whack. So in a building like that, is it ever really possible to balance without doing a lot of other work?
There are some buildings that are just older, and it is impossible to perfectly balance them. But what I can tell you is, even in the buildings with the largest variance, I guarantee you the building, even the warmest apartments, are being overheated. And that is where the control, like smart controls, can come in, because you never want to make an apartment cold, but you can eliminate overheating on the hottest apartments. And that will save you a lot of money, even in an unbalanced building. Now, if you can balance the building, right, and make all those temperatures even better, instead of saving 15 to 20%, you might be able to save 30 or 35%, right? So it's even better. But there is very rarely a situation, particularly in New York City, where you go into a building and it's running on an old control, and that building is not substantially overheated, even with substantial balance issues.
There's a question whether or not you use a subscription-based service model.
Yes, we do. I explained it before. The subscription covers a number of things, like we're bringing in a dedicated internet line. We pay for that ourselves. That is baked into the subscription fee. We have a dedicated person who's responsible for training your team regularly, watching to make sure if there are problems or it's not being used correctly. They make calls, pick up the phone. And then we have a dedicated 24/7, 365 support line that you can call at 3 a.m. In addition to software access and all of that stuff on the iPhone, and web access, which has hosting costs, all that's baked into the subscription fee, but it usually is a very, very small percentage of the savings. So on the average building, it's less than 20% of the savings. So if we save you 100,000 a year, and you're paying us 8 or whatever it is, you're going to be happy to pay the 8 because we're saving you 100. And because our costs up front are very low, it's very aligned. We're aligning our incentives. If we don't save you money every single year, you're going to stop paying us. So we have to do our job, and that is why we have humans dedicated to it. Otherwise, we don't make any money, because you'll just say, I'm not paying your bill next year.
There's a question which reminds us that, like, some of us who live local law 97 way too many hours of every day use terms that other people don't use all the time. So I don't know if you want to take this or Darren does, but the question is, what is venting? And maybe whoever answers it, if you could explain a little bit, like, what are the different types of venting choices and the importance of getting that right on like a 1-pipe system and a 2-pipe system.
Yeah. Can we save that one after Garrett, and then that way we can talk about that whole thing about balancing distribution on those two? I mean, that would be great if we could hold that till the end.
Okay, cool. So there are 2 questions on balancing and distribution, so we'll hold both of them. Okay. Is the O side help monitoring device optional? Oh, I guess the question is the help monitoring service optional in terms of, like, if your super doesn't need help? No.
Yeah, it's not, because there are pieces that are obviously very required, like the dedicated internet line has to be there. You need hosting, so you need to be able to access it on your iPhone, your Android, on the web, things like that. But the other part of it is, we tried doing it the other way in the beginning. We were like, we're just gonna provide technology, we'll sell it. Great, no hassles for us afterwards, right? And we'll make a lot of money. And buildings just didn't save. And we don't want to provide a service that doesn't work. So we'd rather charge the right way to make sure we deliver real value. And if you're making 6 or 7 times what we charge every year, like, it's a good outcome for everybody.
Does Runwise system assume a common suite temperature set point, which it tries to meet, or do residents have in-suite temperature adjustment controls?
It depends on how your building is run. So, like in my building, which has a hydronic 2-pipe system, I have, show you up here, a thermostat on the wall, which controls my fan coil unit over there. Runwise is controlling the loop temperature, and we're finding the precise loop temperature, the temperature of the water in the pipe. All my thermostat is doing is blowing a fan against that. So it's really, we're not changing anything about how it operates in unit. We're simply changing how the central heating system is running to make it much more efficient.
Then the next question is, what about steadiness of heat? Is it possible to keep the variation between when the cycle is on and when it's off below something like 1 degree?
Yeah, we take this, there's a trade-off between variance of heating cycles in a steam system and energy savings, right? Like the extreme would be run your boiler for like 12 hours and then turn it off for 12 hours, right? That is the most efficient from an energy average. If you want to deliver an average temperature, it'll be really hot, it'll be really cold, it'll average out to the right thing. Very energy efficient because there's a startup cost to a boiler running that you lose. Obviously not very comfortable for tenants, right? So we factor that into the algorithm to make sure that we're always optimizing. In most cases, you have a pretty steady indoor temperature. What's changing is what the actual target of that temperature should be, which changes throughout the day, throughout the year, and throughout the season, and based on the outdoor temperature, and that will adjust dynamically every 15 minutes.
So to follow up on that, I know that there are some Riverdale buildings online tonight. I don't know if any of the board members are from the buildings that I'm thinking of, but there are some buildings where we have exterior hallways in a way, and then when you go into your apartment, you're coming in actually from the outside. The door's open, and those buildings are having a lot of problems because it gets cold, right? And then they reheat. So is that something that you would be able to balance, by measuring the temperatures?
We can't fix the structure of the building, which is that you basically have cold air going into every
No,
apartment.
but I'm just thinking like if the boiler's turning on and off more frequently, maybe that would help the situation. I don't know.
We don't just turn the boiler on and off based on the indoor temperature, like, oh, it's 72, turn it off, right? Like, oh, it's 71, turn it back on. Like, that's going to lead to bad things. We're running cycles, but we're determining whether or not to skip long cycles or full cycles based on the indoor temperature, and we're dynamically choosing the temperature. So it fluctuates a little bit, but in general, we're keeping the building at pretty consistent temperatures, even in buildings like that.
Okay. All right. Well, you've survived all of the questions.
You know how I did it. I had a lot of help here, Rebecca.
So Garrett, do you want to go? And I saved the 3 questions as sort of, 2 about venting, and then 1 about how Runwise and Kelvin interact. So we'll.
Okay. Awesome. I hope everybody's doing well. It's a little weird. I can't see all your faces, but I have to say this is pretty cool. I wish I could bring Rebecca, Darren, and Lee everywhere with me. I don't know if I've ever had a better lead-in to talking about the cozies. So just to give context of why I'm here, we're talking about the old buildings, or legacy, if you want to be nice about it. Buildings like Lee's, where he's got that control on the wall, are a bit too modern for us. So I'm speaking specifically to you all whose buildings are 1975 or older. It would be perfect for you. So the idea behind the cozy is that you've got these pre-war often buildings that have been around for forever. And like everyone's mentioned, you've got this uneven distribution, which is super important to deal with because buildings make up most of the emissions for the city. And of the buildings, like Darren pointed out, it's mostly your heating. So it's a very, whether you care about the environment or you are just doing it for compliance, or you just want to run a building, be good stewards and run the building efficiently, it's a very common sense thing to approach. So what happens is you can't make a room too cold because it's illegal and you'll get HPD violations. And these buildings were designed to be overheated. Back when the Spanish flu was around, you want to be able to open up the window so you got some ventilation. But now we know about the climate and gas prices have changed a bit. But what actually happens when somebody has to open up a window is the cold air comes in, it hits the radiator, the steam inside condenses into water. Steam takes up a lot of space. Water just takes up a little bit. That water goes back down your system and then the boiler has to burn more gas, more oil, send it back up. And when it comes back up, it doesn't go to the cold room. It goes right back to that chronically overheated room. So to make sure everybody's warm, you can't play with that boiler too much. Now, Runwise does a great job at mitigating this to a degree, but they are essentially they're in the boiler room with some sensors around, but what they're controlling is in the boiler room. We, on the other side, are in each unit. So you now, as I saw a question come in about whether you can control the temperature in the unit, that's exactly what we do. But we're very limited in being able to just control each unit if we need a Runwise or some internet-controlled boiler so that eventually we can have that throttle up and down. So that's, in a nutshell, what the Cozy does. And this is an insulated smart radiator cover. It's going to go over about 75% of the total radiators. We usually skip the bathrooms and the kitchens for various reasons. Steam in the bathrooms are usually smaller. Kitchens have stoves in them, which throws off the temperature. So you get this Cozy. It's going to go over. You get to choose your temperature for the first time in these buildings, often like up to 100-year history. And then you have a bunch of analytics. Now, this data is not just going to feed your boiler. It's going to allow you to determine your fines. It's going to allow you to have real-time and historical data, and it's going to let you, your retro commissioning agent or RDP professional, have a simpler, it says in the Article 320 filing guide that you can use real-time or historical data from a smart wireless system, and that is us. And this also enables, and this is the coolest thing, my supers always perk up when I talk about this, is the Cozy is going to give you a temperature of your boiler, or I'm sorry, not of your boiler, of your radiator. It'll give you the temperature of each room, and that'll be on this dashboard here. But in the two-pipe buildings, we talked about steam traps. This data is going to, by a nifty trick, we put a temperature sensor on both sides of the steam trap. And then by looking at the temperature delta, we can determine whether that steam trap is stuck open, stuck closed, or if it's functioning properly. So it's super cool. They estimate about 70% of all steam traps in New York City are not functioning. Now, you know, so it makes the building maintenance much simpler. Now, this works on all types of radiators. I'm sure you know which one you've got here. And the end result outcome of putting the insulating all the radiators is the building gets balanced out. And I want to explain a little bit how this happened. I talked about that cold air coming in and the condensation rate increasing. What's happening when you insulate a radiator? Even if you just use a blanket and cover it up, you're manipulating the steam thermodynamically, and it pushes it over to that next cold radiator. So again, steam takes up a lot of space, water takes up a little bit. If the party there is already filled, that steam's been kept at 212 degrees, the steam's naturally going to go down the road to that next cold room. You don't need a plumber at all, and the Cozy doesn't require a plumber to install, as TRVs do. It goes right over and sort of tricks the system. And then you get the hack of putting a fan in there. So it seems almost like you've got a ducted system in a pre-war building, which is pretty cool. If any of the boards have gotten proposals for ripping out radiators and making that improvement, it's generally pretty cost prohibitive. So when you compare Cozy to a TRV, the story I love to tell is that we kind of take for granted the luxury of having forced air, and how silly, or sort of it's a bit archaic to have a hot pipe making the room warm with natural convection, and as opposed to having forced air convection. I tell the example of having a hot metal pipe run through your car. You would never really want that, especially if you've got little ones running around. I love to show my little guy. You wouldn't want to have that hot pipe exposed, and then it also it's less efficient. The TRV is listed in the technical resource manual. It gets its data from NYSERDA. For anybody who doesn't know, I'll do a quick background. NYSERDA is the energy efficiency god in New York State. They but make all the rules. But they did a 7-year study on us, and they are the ones who decided 25.5% is what we save on average. That it ends up getting you fewer maintenance calls for heating complaints. But the most important thing, of course, is that bottom line of saving 25.5% on average. I don't want to get into that stuff quite yet. So this got us into what's called the technical resource manual. If NYSERDA's the energy efficiency god, then the TRM is the Bible. And that's what allows us to have to complete projects with zero upfront cost. And I'll get into that in just a moment. First, I'm going to show you a couple case studies. This is a project. I saw somebody ask a question about Kelvin and Runwise working together, and if these are complementary savings. Runwise was already installed in this building we worked on, and they were already saving them money. We saved them another 40% on top. Now, granted, we projected 30% based off of the TRM. Every building's different, and there's plenty of variables that can happen on any given year, but we ended up going over. And they paid back the project ahead of time. Con Ed helped to pay for almost 2/3 of the project here. This is a two-pipe building with Chris McGinnis, their board president, who's a big cheerleader of ours. We've been with them since 2016, and they were just featured in our recent Bloomberg article. They paid nothing up front to get us in the building, and now they are local law 97 compliant, saving a bunch on the fines they would have been having, and also the net from their subscription comes out to being on top $4,000 annually based off this was a couple of years ago. I'm sure that the utility prices have gone up just slightly since then. And here is a new client. This is an excerpt actually from what our energy savings analyses look like. And we can produce these individually for any of your buildings based off of that NYSERDA validation and the calculation they've created. It'll tell you your cost savings, which this is a 256 unit condo out by LaGuardia Airport. 46 grand is what they're saving per year, just straight off of their utility bills, not factoring in their net. But you see here, I put a comparison, and why I wanted to show this is in my analyses, I show you the usage before the COSI, what the TRV is based off of NYSERDA's standard, and then what it is for the COSI here. And if anybody's wondering why that's only 75%, again, we don't need kitchens and bathrooms. All right, now the rebates. Rebates are awesome. They help us help get these projects done. It's got to be economical. For Con Edison, it's $3 per therm saved, and for National Grid, it's $2 per therm saved. This is based on your past 2 years of gas bills. And so it's projected, even if it's 90 degrees every day for the next 2 years, you still will collect that rebate. And that makes these projects much simpler to get done. We have worked with, we've been around for 13 years now, worked with a ton of awesome companies. You probably are familiar with some of these. Most recently, we had the Fast Company Award over here on the right side, and for their Innovation by Design for Sustainability this year. And we won Bloomberg's New Energy Frontier Award for being pioneers in building decarbonization. Their words, not mine. And another really cool one is the Elemental Accelerator you see in the center of the screen there. That's actually funded by Laureen Powell Jobs, Steve Jobs' wife, who I had the opportunity of presenting the COSI to this past weekend at a climate science fair on the High Line. So super cool. Now, one thing I did notice, and you may be wondering, is these are radiator covers. So they're going to take up a little bit more space. And there's a duct on the front end it's about 2.5 inches. But while you are losing some physical space, you're gaining livable space. You would never want to put a baby's crib next to a radiator or a fish tank on top or plants on top. And so it's really cool to be able to do this, because on top of saving emissions and avoiding fines and saving money on the utility bills, you're gaining an amenity. You get some comfort out of it too. And the only thing that can really go wrong here is this E-kit that you see in the middle. This is actually our older version, and I don't have a newer version in arm's length. The newer ones are touchscreen, and you can actually see the numbers. It's the same technology as Kindle e-ink, and so you can touch it. You could do it from your phone to set the temperatures. And that's all I've got for you all. I'm happy to field questions, and if anybody wants to know more about their building in specific, please shoot me an email at garrett@kel.vin. Thank you. Oh, I think I skipped one part that Rebecca wanted me to include. I mentioned the pricing. There's two models that we have. One is where it's zero upfront, and when we finance it based through the rebates and the incentives. The other one, you all collect the rebates and incentives, and it comes out to being about $200 to $300 per cozy. But we project out the ROI for you based off of the NYSERDA calculation. And that's all included in those energy analyses that we do, and we do those for no cost.
Thank you, Garrett. So there's one question in the chat right now. If any in the Q&A, if anyone has other questions, can you put feel free to enter them. So the first thing says, this sounds like wrapping radiators in overheated apartments with a blanket may be useful, as you mentioned, though of course not as useful as a cozy. And I guess, could you just explain a little bit how that forces the steam to go out? So I guess that would help with distribution, no? Or
yeah, precisely. So the problem is it's much easier to cool an apartment down by opening up the window than it is to warm an apartment up that's too cold, because where they're going to get the heat from. And so people's natural reaction is to just open up the window. Even once they have a Runwise system in there, if they get overheated, which throws their sensors off and gives them some not great data. But you're not being really kind to your neighbor if you're opening up your window, because you're causing that steam to just come up to you and then go out. And if you share the maintenance costs, then you're really not being kind to them. But when you cover it up and insulate it, that steam is now your radiator stays at 212 degrees, and that steam goes to the next space that it has available. The heat moves, the second law of thermodynamics is heat moves from high pressure to low pressure. So once it's covered up and it stays warm, instead of the window being open, you've stopped all that heat from going out to your apartment, and you've allowed it to just go down the line instead of fighting the New York winter to be able to fill that that distribution system up with steam. Of course, it's far less sophisticated than a cozy, because peeling a blanket back to get a little bit of heat when you do get too cold is slightly less. It's closer to opening up a window than it is to having a system that communicates back with your boiler and gives you complete control.
So it's still very cool and a little embarrassing. I was a physics major and that never ever occurred to me. Anyway, there was a question: how long are incentives going to keep running, do you think, for these types of, I don't know, maybe Darren, if you want to answer that, but I know that like Con Ed is now yanking their lighting incentives, and they're talking about removing the incentives for oil to gas. So do we have any idea how long they're going to keep these in place, or we don't know?
I don't have any end dates in mind. I do know that incentives and rebates don't last forever. And actually, the Barclay Garden condo I just mentioned, they were going to do this roof insulation project and solar complete. They had a bunch of rebates and incentives for it, and then they dried up. And that was part of the reason why they didn't want to miss out on what's available. I'm sure new incentives will be coming available too, but if you all have any end dates, I'd love to know.
I mean, I can't give you a specific, but like my intuition is that the city and the state look at carbon reduction as a carrot and stick type of thing, where there's a carrot with incentives and a stick with like local law 97 and other compliance measures. And I think as the stick gets bigger, the carrot doesn't need to be as big. And I think that is likely to happen. We've seen that happen in multiple municipalities. We've seen rebates go down. If you're thinking about doing a measure, whatever it is, with a rebate, I would sure as heck do it ASAP and claim the rebates available. It is very unlikely you're going to get more money later. Very more likely you're going to lose money later.
Yeah, the only thing what I would add to that is that if you think about the incentive program, Local Law 97 is focused on electrification. Electrification needs incentives. The incentive program really is primarily run out of Con Edison from the standpoint of the clean heat program. You have NYSERDA. That's focused primarily, the dollars for incentives is on the heat pump technology and electrification. What you're going to see with the kind of trend is going to be, because we see this with lighting, you've had, for the most part, after Local Law 88, all of the upgrades are pretty much going to be done. There's not going to be a need. So when you have a set number of amount of dollars for the incentive program, the lion's share, because of Local Law 97, is going to go towards electrification. So what the expectation should be, that when you're looking at incentives that are based on gas and gas savings, that as we move forward in time, they're only going to decrease as we go along. So, Garrett and Lee is right on this, is that the expectation should be is that the incentives that are available for the gas reduction are not going to be long-lived, that is really being pushed out and going to be centered around the electrification type of measures. So if there's any intention on doing some of these upgrades relative to reducing your gas consumption and buying yourself as much time as possible, it's definitely one that you shouldn't wait necessarily, because when we're only a couple months away from Con Ed is getting ready to be, going to be announcing the 2025. And so this will kind of be some guidance as we start to see these changes. But the expectation would be that fossil fuel-based or gas-based incentives are going to be decreasing as we move forward in the near future.
Okay. Garrett, this one is for you. And so do you have cozies in different colors, or how do you deal with co-ops where, the room is decorated a certain way? Are there any selection options?
Mm-hmm. Yeah, so the cozy can be ordered, and if it's a large enough building, in different colors, we can manufacture in different colors. But residents can also paint them whatever color they'd like to as well. As long as there's two little sensors on the front, we put in the instruction manual, don't cover up those sensors. But you can bedazzle it if you'd like.
Oh, that's great. So it can be painted any color.
Mm-hmm. Yeah, we can manufacture it
Fantastic.
if it's a large enough order. Otherwise, it's powder coated steel. They could paint it themselves, and it'll be, yeah.
Cool. And the paint doesn't peel or anything. I guess you've had people who've done that, no?
Yeah. Mm-hmm. Yeah, because the outside, remember, is not getting, you could put a fish tank on top of it. The outside will get, it's all insulated, so it will get maybe room temperature, but yeah, it's not
that's
going
great. Not hot
to
at
peel
all.
like, yeah, exactly.
Okay. Darren, there's a question here about TRVs. So maybe do you want to talk about like what they do and how they fit in, or should we keep going and come back to that?
Can I
Sure.
chime in on the TRV? I maybe glazed over this slide too quickly. TRVs, by the way, we may very well, as we get into the European market, start including TRVs in our future plans, but they work really well in hydronic systems. In a steam system, you have this thing that's going back and forth, especially if it's a one pipe steam system, that they're not very effective. They've been around for 60 years now. And if they could have solved this problem of building heating distribution, I think they would have already. They also need everything just to achieve their 7%. I think it's actually under 7%, but the 7% of energy savings, they need everything else in that system to be functioning perfectly and be balanced and vented, etc. And even if it is operating the best as it can, it's still just a single room control. It's not communicating back to your Runwise or your boiler controller. And it's that archaic technology, make pipe hot to make room warm. And when you do have them in a steam system, they cost about just as much as a cozy. We've worked really hard to have competitive pricing with TRVs, but they need a plumber and they need to be replaced every couple of years. So I include them on the analyses. I'm going to be interested, Darren, if you have a comment on TRVs too. I have my landlord say they give the illusion of control to the tenants for my non-co-op buildings.
Sure. So, I think from a Bright Power's perspective, the way that we look at TRVs, for they're better than nothing. So I think I agree with Garrett is that they're not going to provide you the best solution. We see TRVs being more relevant in a two-pipe system. From that standpoint where especially if you combine it with, let's say, an orifice plate, you have already control of the steam. The thought about a TRV is that it is predominantly more useful for people that tend to be overheated as a way for you to be able to turn down that heat on your radiator as far as being able to kind of dial it down. It's not necessarily, I mean, for the people that are cold, they're going to have their valve wide open anyway. So, we find all the times that people just turn off the valve. They use the hand valve for their radiator to try to adjust it. That is not the right way to do this. But from a TRV standpoint, the few times that, I don't want to say few, but the times that we recommend it in a one pipe system, it's for the overheated apartments that allows them to be able to drive some level of comfort on the radiators. And so it is a solution. It's better than nothing, but it's not necessarily the best solution. And I think that's kind of what Garrett was going to. But it is a minimal level of control that's better than just having the hand valve that you're trying to adjust, which is definitely not the correct way to be able to try to adjust the temperature of the radiator.
So this question, so the COSI system lets each unit control their own heat compared to Runwise, which controls the heat for the whole building for all of the units. Would you say that's?
Yeah, and I want to be clear, we are working together. So if a building, most of my buildings already have a internet controlled boiler. If they don't, by the time we're installed, we would have referred them to a Runwise or whoever they want to use if they already have an existing contract with another boiler controller. But I am never suggesting one or the other. Runwise is a single day installation. They're in and out of there. It's sort of a lower hanging fruit. Just to be straightforward, the COSI projects, we have to get in every unit. It's a much more complex. We need to do manufacturing that's custom for every radiator. But they should be looked at as a yin and yang kind of thing supporting each other, as opposed to an either or.
Yeah, and I would say thinking about, and this we can also kind of talk about venting because I know there was a question about that. The goal in a steam distribution system is to get steam to the furthest point possible, as quickly as possible to the furthest point. So in a one pipe system, let's just kind of use this as an example. In a one pipe system, you need air to come out. So that steam, if that air is not coming out, that steam is going to bump into the air, and it's going to be difficult for it to be able to travel to that furthest point. And that's when you find a lot of times you go in and the boilers, what is happening is that the supers are raising up the pressure. So they start upping the pressure to try to force the steam to try to keep pushing the air out. And you have a venting problem. So venting, a lot of times what you're going to see venting is potentially down in the basement at the end of those mains as the steam leaves the boiler and kind of moves horizontally through the bottom of the building before it goes to the risers. So you need it to move quickly across the horizontal part of the building. So there's venting associated there. There's also venting at the top of the risers. And what we see in a lot of these older buildings is that those risers could be behind walls that weren't there necessarily in the first place. People may have a riser, the top of a riser, behind a wall in their apartment that they're just not aware of. They could be in a ceiling, they could be in a closet. And a lot of times what happens is over a period of time, those vents get painted over, so they get clogged up, they fail, and nobody really knows about it. So you don't have air properly coming out of the system for steam to be able to go to the furthest point as quickly as possible. You can also do venting along in the apartments. So when you have these piping and they've changed over, let's say, 80 or 90 years, you are going to have some uneven distribution. So that venting that you're going to have potentially in a one pipe system, it should not be the same if you're going to put them on the radiators in apartments. It should not be the same for those in the lower apartments as they are for the ones in the upper floors. So part of this is making sure that you have the right size vents to be able to have this control. What a control system like Runwise is doing is that it basically is saying the boiler is going to start based upon a predetermined set point of when it's going to start, and then it's going to have a cycle time. The old way, as Lee was talking about this, is that you had a sensor outside that was just based upon that temperature. And, if it's 40 degrees, then basically it's pre-programmed that let's say the boiler is going to run for 36 minutes. If it's 32 degrees, then maybe it's going to run for 42 minutes. Those are all kind of predetermined, as Lee was saying, not taking anything into account what's happening into the apartments. So what you're doing from the combination of both of these is that you're like, okay, now we're going to be able to adjust our cycle time because we're going to take that indoor temperature. What Garrett and the Cozy at Kelvin, what they're doing is that they're saying when you look at this from the indoor temperature sensors, you're never going to see everybody at 72 because you are going to have some apartments that may be south facing. You may have some that are going to be north. You may have wind, so from a wind, you may have solar gain that's going to heat it up. The problem is that not every location is going to be the same. This is really kind of an averaging. So when you think about the average, the question is what is that distance between the high and the low? So that's where when you're looking at the Cozy and you're saying, my apartment, I'm going to be able to adjust this relative to the unique, positioning of where I am and where, you have some co-ops, not everybody is going to be replacing their windows at the same time. You may have somebody with brand new windows that's all of a sudden burning up because they have a better building out, better envelope to keep that tempered air, where somebody still has older windows and they can't, they're always cold. This is where the Cozy is going to come in with being able to control that temperature inside the apartment for the individuals because everybody's going to be a little bit different. So it's really kind of working in combination of being able to say, are we kind of satisfied? Because if somebody is comfortable at 68, which we know some people run hot, some people, they don't, they're always cold, but it allows some variability of people to be able to adjust that along with controlling that boiler and that cycle time. Because what ends up happening is that if you don't have any idea of what's happening inside the apartments, then you're just going to run a predetermined amount of time for the boiler that's going to push steam through the building. And that's when you end up with a lot of people that are just burning up and the windows open, people taking out radiators. They just have a riser. That's all it is. It's heating their apartment. All of this is not how these systems were originally set up. And that's why each component is going to be important as you try to optimize a steam distribution to these terminal units in the apartment. There's levels of control. There's control inside, from that individual comfort relative to also control of the boiler cycle time and how much steam is actually priming the system. So that's, I hope that kind of explains how these two kind of work together to try to optimize and reduce the amount of, heat that is going to be sent out to the apartments. And the only last thing that I would add is that in a two-pipe system, what ends up happening is that you have those steam traps. And we've been in buildings, or I've been in buildings that we work with, but we haven't changed a steam trap in probably 20 years. People don't even know that they exist. That means that those lower apartments, that radiator is never satisfied. All it's doing is radiating heat the entire time that the boiler is running. And the people at the furthest end are always complaining, I'm cold. And it's because that continues to run back to, and what you're going to find is a real clear sign in a two-pipe system. If your condensate tank and that, and everything associated with that condensate tank has a very short life or is always requiring maintenance, it's because it's getting hit with 212 degree temperatures and those seals are not rated for that. And that equipment is not meant to be able to have steam that's going to be entering into it. So that is a sure tell sign that you have a problem with your steam traps in the apartments and your distribution, because you have equipment back in the boiler room that is supposed to be, let's say 180 degrees or less, that all of a sudden is getting hit with 212 degree steam, and it's shorting its life and creating an increase in the maintenance costs.
Thank
A good
you,
way
Darren.
of also thinking about it is just you have a building, right? And there's a certain amount of heat going into it. Runwise is controlling how much heat is going into it. And by definition, even the warmest apartments are, the coolest apartments are overheated. So we're reducing the total amount of heat. What the Cozy is then doing is it's moving the heat around, which not only makes people more comfortable, but means that you can lower the heat further because you can actually create more balance. And so that's how they can work together to actually not only make people more comfortable, but also save a lot of energy.
Thank you. Okay, we have just 3 more questions here. What about a one pipe heating system in a building that has a heating pipe in the bathroom? I'm assuming riser, and radiators in living rooms. It says living rooms and bathrooms, but I think it means living rooms and bedrooms. The pipe in the bathroom is so hot and the radiators are turned off. So how does that play into all of this?
That's the exact type of problem we're solving, because usually the building is overheated because you have too much heat that the radiator's off. That is not what should be happening in most buildings where you have radiators permanently turned off, because it means you're getting vastly too much heat in the building. And that's exactly what we solve, and what Kelvin solves by making it comfortable and giving you heat consistently throughout the day, but not overheating people.
Yeah, so when you have the cozies installed, even though we're not in the bathrooms and the kitchens, it's taking the ambient room temperature. So that riser is heating up. And again, you ideally don't want to have the radiators off, because I don't know if you all know this, but when you have that knob on there and it's not a TRV, that's just an on-off knob. It's binary. So some people try to turn it halfway, thinking they're kind of reducing it and getting that perfect temperature, but it's only messing up the system more and ends up causing water hammer, the loud banging sound that you hear. But risers are tough. We thought about creating a vertical cozy, but it hasn't happened. But once you have a internet controlled boiler in there, and you've got cozies in there, and everything is balanced out, that riser doesn't have to be raging all the time, because the building overall is balanced out, and people are just taking what they need. So that riser is trying to compensate for the entire department, and it's it's a bit of a brute approach. That is trying to be solved by just turning off your radiators in the bath or the bedrooms in the living room.
Yeah, and the only thing I would say is that the riser in the bathrooms, it's there for a reason. That's how you heat up the space. But what it is true that there's too much steam that is going through that riser and is going through the building. So remember, those pipes are going to, all of the steam pipes are in the floors and in the walls, and so your building's naturally heating up. You have probably, if you take a look at your boiler runtime, you have a boiler cycle time problem. It's just creating too much. As Lee was saying, you are putting way too much heat in that building, and it's basically you're looking at different symptoms. When you think about turning off the radiators and stuff, this all goes back to boiler controls, because your boiler cycle times are probably way too long, and you probably have an imbalanced system. This all kind of goes back to what is the root cause of this. And that's why having boiler controls, whatever the solution is really paramount, especially with indoor temperature sensors, because that's, you got to get control of how much steam is in that building for how long. That's a common cause where you have something that's just running way too long, too much.
All right. Okay. My building has coil radiators. Can we use cozies?
Are you talking about a cast iron radiator?
Oh, whoever asked that question, can you answer that, and then we'll come back to you? What you mean by coil radiator, if you could describe it, or you have Garrett's email, so you could always email him.
Yeah, I think what you're talking about is this radiator on the left here. If that's what you mean by coil radiator, yes, you're golden.
For these systems like Kelvin cozies and Runwise to operate successfully, do all radiators need to be open? Well, I guess the cozy would cover them, so you said it before you put it on. Do the radiator valves themselves need to be completely open to work with your systems?
We do, yes. If it's we're putting a cozy over, we just open them all the way up, because it's all controlled by you choosing an exact temperature anyways.
Okay. Oh, okay. So who can assess what the various issues are, like boiler controls, vents? So how would she doesn't know where to start, and that is a problem that we have with a lot of co-ops. Where does she begin in terms of getting assessment for what what can
I
be
think
done?
I think he's called
Direction of
I
Bright
don't know.
Power, because this is why you hire Bright Power. Yeah.
Yeah, I don't know if I was pointing the right direction, but I was trying to
You're
point at
kind
Darren.
of pointing at Lee, I
Our
think.
screen is different, and for everybody, I realize that too, Garrett. But yes, Bright Power is amazing at this. They're well known in the industry as being, superb. Most of the top co-ops and condos use them, and they are an excellent tool company to do that.
Okay. We have the two more questions that I left, which are slightly more difficult, and we're going to get to this one first. Sounds like after installing Runwise and perhaps Kelvin, you might have to add radiators that have been removed. Is that your experience? Oh, I had a condo once where a woman, a long time ago when I was managing buildings, where a woman removed the radiators in her apartment and then called the city on us for lack of heat. It was fantastic. But what would you do in a situation like that if someone has taken out a radiator?
Yeah, so Darren and I were just talking about a project like this about returning the radiators. Generally, though, we leave them out. So it's a case by case basis that will be decided if the building thinks that they will need some radiators added back. We're happy to do that, but usually they were, again, back to my talk earlier, designed to be so overpowered, and the radiators have gotten downsized or removed because there's just we can close the windows.
And from our perspective, the optimal thing is just balance. So like you want consistency throughout the building, and absent radiators, you can get more efficient by putting radiators back or by using Kelvin to balance. Either way, we do many, many buildings where radiators have been removed and the temperature sensors learn and adjust and dynamically control the heat to deal with that.
Yeah, the thing that I would say, no, what I would say is that if you are balancing your distribution, that means that you're going to put less heat into an overheated building, right? You're going to reduce that heat. So it's probably should be expected that if you've removed radiators, then what is your heating element that's going to be present for you to be able to get heat as you get better control of this system? And as you start reducing the amount of heat, you reduce that overheating, it should be expected that you're going to probably be reinstalling those. Because if you think about the heating load of a building and you think about the size of a boiler, the radiators, when the boiler, however old it was, it's all about the heating load and that radiation. And so that being removed is kind of a disconnect with what the size of your boiler and the operation of your boiler and thinking about the heat that's required for that apartment. So I would say that it should be expected that you're going to reinstall them once you get control of your system and it's operating efficiently.
I'm not sure I'm completely aligned with Darren. I would take my approach would be if you're not in that sweet spot of between like about 300 to 500 square feet that's being serviced by each radiator. If you're over that, then I would definitely want to add some back. But if you're in that's normal range. So it maybe means that you had too many radiators to start with, but every building's different.
That's one of our problems, actually. Every building is so different. Anyway, just leave that one there. Okay, we're going to go back to the building that had a problem, 100-year-old single pipe system with very uneven distribution, and they had difficulty. I think, although it's not in here, that they also tried venting and a couple of other things in addition to the boiler controls. Are there any types of buildings where you just don't succeed because they've been burned and trying to figure out how to resolve, how to possibly do cost-effective work? So would there be any reason to think that, boiler controls and radiator controls couldn't work in a building? Have you ever seen that happen?
There are definitely buildings that have not saved money. To give you stats on it, we have a 99.4% retention rate, meaning that 99.4% of our buildings stay, and our gross retention is 130%, meaning if you take all the people that leave and people give us more buildings, on average, each building will turn into 1.3 buildings each year. So it's extraordinarily rare. Where we find it doesn't, like the very rare cases, maybe one out of several thousand we sell a year, will be in a building where somebody usually is just, that's like key is not bought in, and they will literally sometimes even do extreme things like cut wires. They'll sabotage the system. They'll remove sensors. They'll claim the tenants did it. Like, we've seen all kinds of crazy stuff. So those are the rare situations in almost every building. If there's no sabotage or something crazy going on, you are going to save money.
Yeah, the only thing I would say, and I would add to that, is when these systems were originally installed, they were perfectly balanced. So something's changed over a period of time. The question is just identifying what's changed and being able to fix that. So what may have been done may be that maybe it was just improper. I mean, we have services to come in and troubleshoot for the reasons that, not all contractors are the best. So, you get called in to be able to help fix things because we've seen where people put vents in the wrong location at the wrong sizes, even though somebody has paid for something, they're still not realizing it because whoever did it didn't do it correctly. So there should be a way. Something has changed. And so then the question is what is that, and identifying it and being able to fix it. So it's getting back to the root cause of why you continue to have this issue.
Thanks, Darren. Okay, and I think the last question is for you. Wouldn't it be cheaper for buildings to convert their gas boilers to electric boilers rather than trying to replace steam systems with heat pumps?
So the answer to that is no, because, and it depends on what we talk. So the problem when people talk about electric boilers, here's the thing that we need to make a distinction of. Electrification that, for Local Law 97 is about heat pump technology. Because when you look at, if we're talking electric boilers that maximize or, they're only 100% efficient, they're like electric resistance. You're talking about on average heat pumps that are about 300 times, they're about 300% efficient. When you talk about electricity on electric boilers, that's only 100% efficient. And you look at the cost per kilowatt hour, and then you think about the demand charges, your expense going from gas to electricity with electric resistance is going to go up probably about, on average, let's say 5 times. It's going to dwarf any sort of fine that you potentially could expect from Local Law 97 and carbon emissions, because your operating energy cost based on electricity is going to explode, and it's not going to make sense anywhere. That's the reason why when you talk about Local Law 97 and you look at what DOB, NYSERDA, and everybody's talking about, it's heat pump technology. Because when you look at that efficiency with heat pumps, because of the cost of electricity relative to the cost of gas as an input, it's that efficiency that brings down the cost of being able to operate that equipment relative to a gas system. So, just from the standpoint to make sure that we're all talking about the same terminology, electric resistant boiler, 100% efficiency is not a good idea, because when you start looking at those annual operating energy costs, it's going to be crushing.
And the same thing's true when you're doing the domestic hot water too. No, I mean, it's important to use heat pump technology.
Yeah, the heat pump technology for domestic hot water it's going to get better, but yes, that is the goal, is to do the heat pumps. It depends on how big your building is. I mean, you could probably get away with some of the smaller buildings taking a look at that. And there's some other solutions that may not be heat pump that could be fairly efficient, but yeah, the domestic hot water, the goal is at some point in time in the future for the heat pump, but there's a lot of other choices between now and then. The main thing is on the heating side, because as you can see, that's the biggest load. That's the biggest contributor to carbon emissions. That's the biggest opportunity. But, for most buildings, the question is how long can you defer that before you feel like you have to do it? And when we talk about the solutions that are being offered here tonight, that is allowing buildings to be able to defer, having to feel like they have to do some sort of electrification project.
Yeah, absolutely. All right. Well, thank you all so much for attending tonight. We will be distributing the slides tomorrow, and after we take a look at the recording, we'll be posting it on our YouTube channel probably in a week or two. It takes a little time to finish it off. And good night. And thank you, Darren, Garrett, and Lee, so much for joning us.
Thank you, Rebecca. Amazing.
Thanks, Rebecca. Thanks, everybody.
I like the balloons.
Balloons.
Good night,
That
everybody.
was-
All right.